Alright, today I'm gonna do Codewars. Continue doing the Codewars challenges in Python. The RGB function is incomplete, completed, so that passing in RGB decimal values will result in a hexadecimal representation being returned. Valid decimal values for RGB are 0 through 255. Any values that fall out of the range must be rounded to the closest valid value. Note, your answer should always be 6 characters long. The shorthand with 3 will not work here. So I need to parse the values into the... Damn, that seems very difficult. Following are examples of expected output values. 6 characters long. So anything that is over 255 should be 255. And values that fall out of the range must be rounded to the closest value. So, as so many negative values have to be 0 as well. And the thing here is that I'm gonna have to look it up because I don't know what's the logic behind the translation from RGB to hexadecimal. Hey, good morning. I'm Tolu. RGB to hex converted. Why does everyone say GM now? When does this started? RGB to hexadecimal. Logic behind. Story will suggest several words. So they're using this toString method. I just need to understand the logic better. It's very complex RNG. Yeah, out of nowhere, everyone starts saying GM. I guess it's just like with everything else, anything that becomes popular. I think like no cap or something, some things like that. People start saying because one person starts it out of nowhere, then all of a sudden everyone's is saying. It's kind of funny. It's like a tribe thing. Yeah, so I think the issue with this challenge is that I'm gonna have to, because if I look it up like this, it's gonna give me the answer right away. I don't know if I can find if there is, but there must be a logic behind the way that it works. For every value out between 0 to 225, there must be letters, equivalent letters. But I don't know if I can find this. And it doesn't seem like it's a good challenge, to be honest. Because I'm not gonna be practicing anything. Or maybe if I can find the logic, then it makes sense. because then I have to translate that logic into the code. Which RGB or hex is the lime green and the yellow? So how can I search this? If I just search Python, and the problem is that I think the solution is gonna come up. R stands for red, green, and blue. Ranges from the decimal value of 0 to 25, therefore. So the total possible values available is 16 million. Hex color is a unique way to express color using hexadecimal values. Oh, okay. I think I understand now. So hexadecimal is in the value in the memory, probably. The code is written in a hex triplet, which represents each value that specifies the components of each of the color. Ah, that makes so much sense now. So I think the hex value is the hexadecimal representation of this calculation here. Interesting. Didn't know that. The code always starts with a hashtag sign, and after the sign, 6 hex value or 3 hex value pair is written. I'm not sure if it has any difference though between the order of them, or if it's just the equivalent to the value. So if I should take the value there and multiply R to R with G and B, and then translate that into hexadecimal. Or if I can make them separate and translate each one to a hexadecimal, and then combine them. I think it makes more sense to multiply them first and then convert. Oh, here's the solution probably. Many methods available for the conversion of RGB to hex and vice versa. Let's understand some examples. I think I'm just gonna read this, to be honest. But maybe I should. So the first thing is the conditions. So if R bigger than 255, bigger or equal, R, G. Oh, actually, I can't put them in the same because if any of them are bigger than 255, then it's gonna make the other ones. So I have to separate them on each if statement. And now lower than 0. Uh, 0. So I think this takes care of this condition in the beginning. The closest value for that. Maybe there's a better way to do this. That's the thing though. can use a switch as well. Yeah, but I don't think it changes anything. I guess I'll look at the other people's solution to see if, which way they did this. And that's the thing though. I guess when you put only 3 values, it means the same thing, but it gets the values that are bigger. Because hexadecimal, as far as I understand, I think is base 16, where each number in the line is elevated to 16 times something. Times, yeah, I don't remember now. I think that is times 16 or... I don't remember really well, to be honest. So maybe translation between decimal to hexadecimal. Hexadecimal. So what I would do here is make value equals r times, and then whatever logic I have to do in order to translate this decimal value into hexadecimal. And then return that value. Divide the number by 16, get the integer quotient for the next iteration. Get the remainder for the hex digits. Repeat this step until the quotient is equal to 0. Okay, so I have to think about the math. And I also need the table. So for the table, I'll do a dictionary. And then just look it up. Yeah, the problem is I have to write all of this. Oh, it's just, yeah, the alphabet until, oh, here, till 15. So what I probably have to do is translate this into a dictionary with all these values. Then do the math here and look it up on the dictionary. So divide the number by 16. Get the integer quotient for the next iteration. I think I can use that div mod function for that, where I get the quotient and the remainder at the same time. And then I do that on a loop until, and put a condition statement for when the quotient is 0. Takes 2 numbers and returns a pair of numbers consisting of their quotient and the remainder. X is numerator and y is the denominator. X and y must be known complex. The mod method takes two parameters x and y, where x is treated as numerator and y is treated as the denominator. It's a little bit difficult for me because I have to think about the translation from that thing into Portuguese, and I'm not very good with terminology. To think about what each thing means. The method calculates both these and returns both values. Also, I guess the difference between... I didn't know that as well. I think this gives the full part of the division and this gives the remainder. So this plus this is the total division. If x and y are integers, the return value is... If x or y is a float, the result is... Okay, so Q in this case is the remainder. P is the quotient. I think I'm gonna copy this and then just modify based on what I want. Yeah, so I think this while loop works. Instead of this, I should use value. And then I have to change this thing here. And next is gonna be 16. Actually, I think I need to put them here. So value is gonna be... X here is gonna be 16. But I think it's the other way around. I think here they're testing to see if 15 is a prime. Initialize a new variable, say x with the given integer and a variable counter to 0. Until the given integer becomes 0 and keep decrementing it. Save the value returned by div mods in two variables. Check if q is 0. This will imply that n is perfectly divisible by x. And hence increment the counter value. Check if the counter value is greater than 2. As number is not a prime, as it is a prime. So I think what I need to do is divide by 16. So I think x should be 16 and then should be the value. But I'm not really sure about this because of this function here. I don't know if I understand which one is which, but I think it makes more sense to me that n is the value, x is 16. Then I don't need to do this. So the only thing that I don't know is that I should probably change the value of p on each one. I think. Just suck. So I have to think about what I have to do here. Divide the number by 16. Get the integer quotient for the next iteration. So the integer quotient is p, I think. The remainder for the hex digits. So the hex digits is the but then I have to look it up on the table. That's the missing step, missing component here. That's why I'm getting confused. So I think I'm gonna put a comment here. Is quotients. Get the remainder for the hex digits. Repeat the steps until the quotient is equal to 0. But what if the remainder is never 0? That's the thing. Because if it's not a perfect division, I guess I can make less or equal than 0. And then here just break. Or here would return, I think. Return the value. So hex table. It's gonna be the dictionary. So each iteration I should probably create a string and then get the values out of this table. Use the Q value to look up the value of the table and then append it to the string. Yeah, that makes sense to me. The only issue is that I can't think about a way to other than write all the values. Like a way to create this in a loop maybe or something like that. And I don't think there's any way other than writing every single value manually. So maybe what I should do is this. I think I'm gonna write this down. If it doesn't work, I'm gonna I'm gonna test it. If it doesn't work, I'm just gonna read the solution there on the other blog. And I think it's better to do it exactly like it is here, instead of making the hex the key value. So 12 is C, 13 D. E, 15 F. Oh, that's the problem. Oh, but it's a different key. Because the value is the same. Let's check and just see if I didn't make any mistakes. So 16 is done, 17, 11, 12, 19, 13, 20, 14. Maybe there's a much better way to do this, though. Every time I have to write a bunch of things, it feels like it's not the correct solution or the best solution. There's probably a trick that I'm missing. Uh, 26, 27, 29, 30, 40. I think this is a 0. Not sure though. But I guess here is the thing that I should that I don't understand, is that I should probably make P equals P divided by 16, but because that's the thing, I'm not changing the value here at each iteration. That's why it doesn't make sense to me. Because it is also saying wow x, so maybe I'm also confusing the which one is which here. Because this has to be while value different than 0. So maybe I should look it up the div mod again. And I don't think I need this table anymore. So the first is the number you want to divide. It's like I thought it is. The second is the divisor. The first is the value, and the second is the number. And also, the only thing that I don't understand is in the other example, how is it making the value decrease each time? Oh, it's making x. I forgot that I erased this. So it is changing the value. So in my case, x should always be the same, but p should, because it's always going to be 16. And p should be equal to p divided by 16. I should put x here. And then while p. Yeah, now I think it's correct. And here should be. I don't need the if statement though. It's greater or equal to 0, I think. Maybe it's greater than 0, better. And then I don't need the if statements. And at the end I return the string. And here I look it up the value. And that should be before the division. Let me think. Yeah, so now I have to look it up the steps again. Where was it? Oh, I think I closed that. The thing that I was reading there. I think there. Yeah, the Q is. No, that should be P. Oh, Q is the remainder, I think. Yeah, Q is the remainder, so Q should be the one that I use to look it up on the table. So result plus equals X table Q. Yeah, I think now it's correct. Let's test. Oh, I can't use P. Yeah, obviously. That should be N here. And then N is equal to and divided by x. Oh, it has to be this one though, I think. Yeah, I think that's the only way. I'm just trying to think if because P is gonna be the result, but N is gonna change each time, so I think this is correct. Let's just test and see what happens. Oh, yeah, I forgot that I should make this, or I should probably do this. It's probably easier. It's kind of confusing here. Yeah, now I think it's correct. Yeah, I knew that it didn't feel like it was the right thing here because I would probably miss some cases, but I was expecting to get at least one of them correct. Texting max values. Oh. So the issue here is that it can both be because I'm not understanding how it connects the the parts. This value here might be the wrong approach, and it's probably because I'm missing some edge cases here as well, where the remainder is not exactly or equal to 0 or something like that. And the out of range values for some reason are also not working. Because when they are 0 it's a problem as well. Because then it makes the value equal to 0. So that's the mistake. Yeah, so though you probably shouldn't be this way here because it doesn't make sense. For when one of them is 0. But then it doesn't make sense. So maybe each letter is one lookup at the table. But then it doesn't make sense because you can't have anything higher than 255. But maybe it does make sense because it doesn't matter. Yeah, not sure. I think I'll just read this one to see how it works. Right back. I guess it doesn't make sense for them to be the three values concatenated because they have to be equal to 6 letters or 3. Hex color is a unique way to express color using the hexadecimal values. The code is written in a hex triplet, which represents each value that specifies a component of the colors. The code always starts with a hashtag, and after this sign, I also forgot the hashtag. So it's a hashtag entry, but I'm not sure if I should probably. Oh, okay, so here is without the hashtag. And so that's super easy there. Yeah, this one probably works. With dust. Here's the whole number. I don't understand this actually. I guess it's concatenating them. It's 255, 255, 195. The above example created a function that passed RGB value as an argument inside it, and we converted RGB into hex using the string conversion. Oh, so I think I understand now. It's replacing the each value. It's replacing each value here in these things here. What is X there? Oh, and also, yeah, okay. Mm. So the other way around, probably. And the problem is the only problems are the edge cases, probably. But I still don't understand this really well. This notation here with the X. And I guess it should be so. Another way you could do is also concatenate them. Do the table lookup and then concatenate, but I don't think that's the best approach. This one's much better. I just have to understand what is this. To handle the edge cases, what is this thing here? Is the remainder divided by 2? Don't really understand. Yeah, but maybe if I do the... But then maybe it feels like cheating as well. If I test for the values here, or if I return this after I tested for the values. And it still fails. So maybe instead of using a leaf, I should use if. Because then it's probably stopping at the first one and not testing the other ones. And I have to test all of them. That's probably what's wrong here. And it still doesn't work. So 0, 0, 0 passes. Oh, it's because it's caps lock. That's why. I didn't even read this. Yeah, there we go. Nice. Yeah. I don't think I'm gonna spend a lot of time on this, to be honest. Just gonna leave it with this result and read the other people's solution, and maybe I should search for what exactly, how this exactly this works. I think I've seen the percentage in these should replace values, but I think it was only used in Python 2. I don't see it because in Python 3 you use the curly braces, I think. It still works, but and I think what's happening here is just that each value is from 0 to 225 and just gonna look it up on this table and it's gonna replace and concatenate them instead of multiplying and translating the total into the table. It's just each separate value added together as a string. So the other way to do this is probably to look it up each one and then transform into a string, and or you don't need to transform it actually. You just sum. But then the issue is, what if there are lower values here? How does it work? Because then you're not gonna have 6 digits necessarily. And I think it's always 6 digits regardless of the values. That's what I don't understand. Or they can go above 6 digits depending on the value here as well. And what if they're a value that is not on this table? Well, then I guess you can do the remainder stuff, but still doesn't make a lot of sense. Actually, you have to do this translation here. And translate the number into the decimal by doing this thing here, and then you concatenate them. And anything below 255 is only gonna be either two values or one. So the only thing is what happens if it's one of these values that are gonna be lower than 6. I guess you just put a 0 in front, but it just seems a lot more complicated. Hopefully it works on all the other ones. Nice. And I guess you can use these shoe dots on Python as well, which I didn't know. Oh, so just getting the remainder of the division, and but dividing the remainder divided by what? That's the thing. Oh, so this percentage X means hex. It's filled with width of true. Oh, okay. So it's doing the operation that I talked about, but in a much easier way, where it's getting the remainder of the division of the value and then filling with true. Let's compile a string with hexadecimal representations. Int r times 255 is a number, and the program wants to write a string with the hex equivalent. And what is r here? Pattern on the left by zeros. Yeah, so just like I was thinking about. Yeah, okay. Let's see the other solutions and then move on to the next one. This is doing pretty much the same thing. Yeah, I think this is the new way to do it, probably. With the curly braces. And here is rounding based on this function, which are the boundaries. And replacing. So making this times 3 and then replacing each other. I think the way with the percentages is the old way, the Python 2 way. This probably is the new way to format it. And this way looks a lot cleaner as well. A lot cleaner way to test for the condition. Also this way as well, which I didn't think about. Using a function to determine the boundaries instead of using a bunch of if-else statements or if statements. It looks a lot better. It's probably more efficient as well. Although I think it depends, because if you call a function increases the stack size, but I don't think it should matter that much. I think it's probably a better way to do it than choose if statements. And this is the same way I did it. Yeah, I need to read more about Python string formatting because I remember I did a challenge on Free Code Camp, but I most of the time I'm just using the basic stuff, which is the curly curly braces, curly brackets. Because usually there isn't any other application, but maybe there is, but I'm just not using it because I'm not used to doing that. And usually I ended up doing things in a more complicated way just because I'm not familiar with using string formatting in a different way. Because I don't know the methods off the top of my head, I can't. That's not the first thing I think about whenever encountering some problem with strings that I have to parse strings somehow. But I think also at the same time, most of this stuff is already handled by libraries, parsing libraries. This the things you need to know about string formatting. Usually there's gonna be a library for that, I think. That's probably why I don't use very often when building things. I need to look at the official documentation. So this forces the field to be left aligned within the available space. This is the default for most objects. To be left aligned. Forces the field to be right aligned. Forces the padding to be placed after a sign, if any, but before the digits. This is used for putting fields in the form plus this. This alignment option is only valid for numeric types. It becomes the default for numbers when 0 immediately precedes the field with. Forces the field should be centered. Interesting. You probably do this to split the number as well. It's just a more complicated way of doing the same thing. I actually know. Maybe it's the same thing they did here. Yeah, it's using the comma. That's why. And then 02 is for the size, to fill the size. So the comma is the same thing as the percentage here. The comma inside the curly braces. Yeah, here. And this feels like it's probably something. The issue is that I'm not gonna remember this. I'm gonna have to look at this several times until I remember off the top of my head. But it feels like it might be something very useful because in a lot of different instances, it can become a lot easier to do things through this with doing these mathematical operations and transforming into string instead of doing because it just simplifies things a lot more, especially with machine learning stuff. It might be very useful for the data cleaning parts of things, I think, or for date formatting as well. I think I spent enough time on this for now. Probably just gonna go through the next challenge. I think now they're gonna become really hard from this point on, where I'm getting to the 5Q challenges. So I'm probably gonna have to spend more time on each challenge. For this exercise, we will be strengthening your pageful mastery. You will complete the pagination helper class, which is a utility class helpful for querying paging information related to an array. The class is designed to taking an array of values and an integer indicating how many items will be allowed per each page. Array of values. Class is designed to take in an array of values and an integer indicating how many items will be allowed per each page. The types of values contained within the collection array are not relevant. Following are some examples of how this class is used. So passing an array with values and an integer. So, okay, so the array is how many items and the integer, no, the integer is how many items for each page. And the array is how many items exist. So the length of the array divided by the pages is the amount. Divided by the number is the amount of pages. Hmm. Close this window a little bit. Too much reflection for me. Page index takes an item index and returns the page that it belongs on. This is pretty much the index of the item in the array. I think I understand now how it works. The constructor takes in an array of items and an integer indicating how many items fit within a single page. So I think I need to do the each function here. That's the challenge. So item count should equal to 6. So return collection length of collection. Page count is the problem is I have to round up because it's gonna be the length collection divided by items per page. So in the case that is not a perfect division, I wanna round up, I think, and that's probably the easiest way to get it. Right, and I knew that there is a function for this because I've seen it before. Math.co function to round up a number in Python. The arithmetic way is not the best. Probably better choose the function. Not sure if I need to use need to import to the library or if it's built in. I think it's built in, so. It turns the number of items on the current page. Page index is 0 based. Okay, so the argument is the index of the page. So if, or maybe I should also make I should be putting self here. Forgot about that. And I should also do the init here. And the indentation is weird here. Soft items per page. So if page index is bigger than soft dot items per page, oh actually it's bigger than page counts. Return -1. I don't know why the indentation is weird. Else. So now I have to return how many items exist on the page. So let me think about it. I guess I can just loop through the thing. It's actually gonna be the page index times items per page. Yeah, I think that's just items per page times page index. No, but then if it is 0, it shouldn't be. Yeah, this should work. Oh, actually no, because let me think. Oh, if the items are, if there's only one page, then I think it's gonna be the same anyway. Yeah, but if there's 2 pages, then it should be different. If it isn't divisible by 2, that's the problem. Because 0 is gonna have the full number and 1 is gonna have the remainder. So maybe I should do this right here. And then else I return the remainder. Yeah, that's the problem. Yeah, I think I should do result equals page index equals this. And then I return the division, the remainder of the division. But that's the thing, because the division of the length of the collection with the page index, with the result. And just do item counts, percentage result. And this one doesn't seem, I think it's gonna fail, but I wanna test the other ones. It's very confusing if you get this one right. So this is the total items of the collection divided by the page index times the number of times the items per page. I think this works. So it's the total number of items divided by the index of the page. Yeah, but actually no, because then I'm gonna have the entire array and not the index. That's the thing. So I need to remove the other ones that are not at the end of the thing. That's the problem. So if I get index true and there's 3 pages, this is gonna give me true plus the whatever items I have in the 3rd page. So maybe it's item counts minus this. I'll think about this later. I'm gonna see if I can do this one and then test and see which ones are failing. Determines what page an item is on, zero-based index. The method should return -1 for item index values that are out of range. So item index bigger than length collections. Well, actually, you can just call the function. Then else, I do something else. The result page, an item is on 0 based in. So this is the index of the item, and I need to return the page. So I think it's just gonna be this divided by the items per page. Now let me think. And then I need to use the math.su or math.floor. So round down, it's probably math.floor. I don't understand this thing here. This. Yeah, math.floor. It's probably the one that I'm gonna use. So I think this works. Actually it doesn't. Because the issue again is I'm counting all the other ones that don't necessarily exist. So let's say item index is 4 and items per page is 3. And 4 divided by 3 is gonna give me 1 point something. Or maybe it does work. I think I'm gonna test this and see which ones it fails. It's probably better. Okay, so I need to import math. Item count is not defined. I probably forgot the self somewhere. Oh, here. Oh, self dots. I hear again. Oh, everything passes. Page count's not fine. It's weird that they don't test this. I guess it's because it's an edge case. Yeah, I knew this one would probably be the one that is incorrect. Page index 0. Called when there was an empty collection. 0 should equal -1. I don't understand this one. I guess it's because I'm calling here. Calling this item count function. Or maybe it's because I should put equal here. Yeah, but then that's the thing. Oh, actually, empty collection. Oh, actually, this one passes. Okay, so now this is passing. So the ones that are incorrect are page item count and page index, which is this calculation here, which is more confusing. So let me start by this one. Page index returned incorrect value when provided item index argument that was out of range. True should equal -1. So maybe it's the same problem I had here. Returns the number of items on the current page. Let me try to put this here as well. Let's see if it changes that. It's still failing, so returns the number of items on the current page. Page index is 0 based. This method should return -1 for page index values that are out of range. Oh, actually, Because it has to be bigger than the length, I think. But it's not necessarily bigger than the length. It should be bigger than items per page. But I think I'm already testing for this here. Now let me think. Stop the music for a second. So returns the number of items on the current page. Page index is 0. Base. Also, maybe an easier way is if it's less than the whole length, is just gonna return the current page, the items per page. And if not, then it returns the remainder. So I think I'm gonna erase this stuff here. So if page index, yeah, but it has to be, yeah, let me think. So first, if it's smaller than length of self.collections collection, then I need to return page index, return self.items per page, because that means that any page is gonna have the items per page, unless except the only edge case is if it's the last page. So here I leave. Oh, actually, yeah, that's the problem, because this condition is not right. Because even if it is, I have to think about it. It's some annoying, confusing mathematics here. It's simple, but it's confusing to think about it. So I need to divide the length of the collections for the items page. So if the remainder of the division is different than 0, remainder, which I think I did. I think I'm just gonna do it like this. So if the remainder of this division is different than 0, oh, actually, let me think. So I think when the list is empty, I should return. The first case I should probably handle is when the collection is an empty list. I should probably return 0. Or maybe actually should return -1. Returns the number of items on the current page. And page index bigger than 0, return -1. And now I should think about the other ones. So I think if page index is bigger than the remainder, and the remainder is different than 0, then I take the remainder. So if page index is bigger than this, but then it gets too big here. Try to think if there's a way to say this in a more concise. Page index is bigger than the remainder of the division. That means it's the last page, I think. And if it is equal to 0, if this is equal to 0, then it means that any page is gonna contain the same amount, which is gonna be return soft dot items per page. And if it isn't equal to 0, then I need to handle this case here. And maybe I should put this one in the below the other one. Makes more sense. And then I should do this actually. It's different than 0. So if it is equal to 0, if it is equal to 0, any item is gonna, any page is gonna contain the same amount, which is the items per page. If it is different than 0, then I do this if else statement inside. So if it is bigger than else, I'm gonna return this. And if page index is bigger than the remainder, then I return the remainder. Oh, it's bigger than the quotient, I think. Then I return the remainder of this. Let's see. Oh, here. Okay, so it's still failing 1. Oh, actually 3. Turning correct value and provide an item index argument that was out of range. True should equal -1. Oh, no, actually it's this one that I'm testing now. So page item count is returning correct value. 10 should equal to 4. 4 should equal -1. So I think I forgot when the page index is bigger than length of the collection. Return -1 as well. Maybe this is gonna handle one of them. Keep forgetting that I need to do the other one. Four should equal -1. So what case is this? Or maybe, well, but if it is equal to the length, I think you should return. Oh, actually, I'm doing this the wrong way. It's not bigger than self.collection. It's bigger than the item count, I think. Or page count. Keep forgetting. But it still doesn't work. So what if the index is equal to the page count? There's the number of items on the current page. So it's returning 4, it should return -1. Trying to think about what case that could be. And I think that it is when it is equal to the length or something like that. I think this condition is wrong here. But I'm trying to think about a different way to say this. It's not that it is wrong, just that it doesn't check for all the stuff that I need to check. But I don't understand. Returns the number of items on the current page. Page index is 0 base. It must return -1 for page index values that are out of range. So if they are the same, if the page index is the same of the is equal to page count, it should return the values of that page. And if it is bigger, I'm returning -1 here. So maybe it's the other ones, but I don't think it is this one, because otherwise it would be saying I'm returning 0 and it says I'm returning 4 instead of -1. And this is also incorrect. That should equal 4. So what am I missing here? I think I'm gonna take a break and then come back later. It's not that this one is difficult, it's that it's just annoying to think about the right way to put this with the pages and the length of the collection. Should equal -1. I can't think of any case in where that would make sense. Because if it is equal, the page index is equal to the page count, you should just return the elements of the page, because the page exists, obviously. Maybe it's this shoe here. And it can't be the case where page index is 0, because I'm getting 4. So page index is 4. No, it's not 4 actually, it's some other number. is greater than 0. And collections has elements. Yeah, I'm struggling to think about a way to that doesn't hit any of these 3 conditions here, and it still should be -1. Just doesn't make any sense. That should be lower than page count. Because I think page count is correct because I'm getting all the methods correct here. And if it is equal, then also doesn't make sense to return to -1. Oh, it does make sense actually because it starts at 0. Yeah, so it's gonna be 1 lower. So I think it does make sense. It's probably the... yeah, okay. So now is this one. So now I think I have to focus on this true here. Or, yeah, these 4 conditions. Tan should equal 4. Why can that be the case? It's probably the remainder stuff. So if the remainder is equal to 0, I don't think it's this condition. This seems to be correct to me. Because if the remainder is equal to 0, then it's a perfect division, which means that every page is going to have the same amount of items. If it is different than 0, then I think that's probably the wrong thing. Yeah, that's probably what's wrong here. Page index bigger than... So I'm dividing the length of the collection by the items per page, and I'm getting the quotient. And I'm making the page index bigger than this. Maybe it's just bigger equal. Again. Uh, okay, so that was a problem. So now focus on this one. I think this one is very similar to this. Determines what page an item is on. Zero-based indexes. This method should return -1 for item. So let me read the test cases that I'm failing to see. To decide which one to focus first. Return the incorrect value and provide a item index argument that was out of range. Choose should equal -1. So I'm not handling the conditions where the item doesn't exist. So maybe again is the equal sign here. Could be this. I think that's the easiest thing to test first. Okay, that worked. So return the incorrect value when provided item index argument that was out of range. Page index minus 23 should equal minus 1. So I'm also not handling negative. And I didn't handle this here as well, so maybe I should. Oh, that's the problem. Is that indexes can be negative. That's the thing. So what I can do is turn them into positives and reverse the array. Yeah, but the problem is I'm handling these conditions by calling the other ones. Oh, actually, I think it might work. It might work if I just transform the negative index into positive ones and reverse the array. The list should be the same thing. The other one is also negative values. Minus 2 should equal minus 1. Let me see if I just do the conversion here. I think. So both of these cases are, it should be minus 1. So one thing I could do is just test to see if it's smaller than 0 and then return minus 1 if that's the case. But yeah, then I think it's gonna fail the other ones potentially. And it feels like it is a hacky way to do it, but I just wanna see if it passes. Yeah, there we go. Now the question is, do I wanna waste more time trying to figure out the correct way to do this? Because obviously the problem with this is that you can have negative indexes that are gonna exist. Determines what page an item is on, zero-based indexes. This method should return minus 1 for item index values that are out of range. So you can have a negative index that is within range, and then it shouldn't return minus 1. But I'm returning minus 1, and that's the problem. Maybe I should say this somewhere, the discussion or somewhere, so they can create a test case that Or maybe I'm not thinking about it properly, but I think I am, actually. Or maybe the item indexes are supposed to be positive numbers only, because not necessarily equivalent to. That's the way that the function is supposed to work. Not equivalent to the index of lists. So I think I'm gonna leave it like this and just see other people's solution and then take a break and come back later. Hmm. I think I'm just gonna. It's not that interesting, honestly. It's more difficult because it's annoying to figure out the correct math, but there isn't anything when it comes to programming that it is interesting about that one. I think I'm gonna take a break now and come back later because I'm really tired. So see you then.